Okay, so we're all seeing this massive rise in what's called agentic AI. These are really powerful systems that can just take complete control over tasks for us. And honestly, it feels a bit like magic. But this new power, it creates a huge security blind spot that most people just aren't talking about yet. So let's break down this new kind of risk and, more importantly, how we can fix it.
You know, this quote really hits the nail on the head. As these AI agents get smarter and more autonomous, the potential for things to go wrong, well, it gets exponentially bigger. So today, we're going to dig into that risk and really explore the solution.
The risk we're talking about isn't just about hackers or, model hallucinations in some abstract way. It's about something far more fundamental to how these systems actually operate inside a company.
What is the real risk here? It really boils down to one simple question. How does an AI know what it's allowed to see, right? When you ask your internal AI chatbot a question, what's stopping it from pulling confidential data that it has no business accessing? So if you look at this list from the Open Web Applications Security Project, or OWASP, they're kind of the experts on this stuff. It shows the top security risks for large language models. And yeah, they're all super important, but the one I've highlighted here, sensitive information disclosure, that's a problem that we as developers have direct control over.
So here's the bottom line. When an AI agent goes to retrieve data, it absolutely has to know who is asking the question and what that specific user is authorized to see. If you don't have that, you basically have a massive data leak just waiting to happen.
To really understand how to solve this, we first need to take a quick look at how we've handled access control in the past and, why those old methods just don't cut it anymore for AI.
Authorization has come a long way over the decades. I mean, it started with these really simple access control lists back in the 80s. Then it moved to the very common role-based model, or RBAC, in the 90s, and then to a more flexible attribute-based model. Each step added a little more context, but they all still have their limits.
Let's just focus on RBAC for a second, because it's one of the most widely used systems out there today. The idea is simple. You're an engineer, so you get access to engineering documents. You're in sales, you get the sales data. It sounds pretty straightforward, right?
Well, here's where it all falls apart. What if a project manager needs access to some engineering docs, but not others? RBAC forces developers into writing these endless, messy if-else statements in the code. And as the company grows, this just becomes a tangled, unscalable mess that's filled with security holes.
Thankfully, there's a much smarter, more modern approach that is perfectly suited for the complexity of today's applications, especially AI. And this slide just lays it all out perfectly. We're moving from a coarse-grained model like RBAC, which is super rigid and clumsy, to a fine-grained model called RBAC. And RBAC is all about flexibility, scale, and understanding the context of a request.
RBAC stands for Relationship-Based Access Control. So instead of a static role, it defines permissions based on the direct relationship between a user and a piece of data. So access is inherited naturally. If Kate can view the Q3 folder, well, then she can view the roadmap document that's inside it without needing some separate, rigid rule. It just makes sense.
And this isn't just some academic theory. RBAC is implemented through a really powerful open-source tool called OpenFGA. And get this, it's based on Google's Zanzibar system, which is the same tech that manages authorization for Google Docs and Google Drive. So yeah, it can handle incredible scale.
Okay, theory is great, but how does this actually work? Let's take a look at how this model helps build a secure AI system in the real world. It really just breaks down into 3 simple steps. First, you define your authorization model. That's like the rule book of who can do what. Second, you define the specific relationships, like Kate is a viewer of this folder. And third, you just ask the system a simple question. Can Kate view this document? Yes or no? Now let's apply this to a super common AI use case, Retrieval Augmented Generation, or RAG. This is basically when an AI chatbot searches your company's internal knowledge base to find answers. It's incredibly useful, but it's also a prime candidate for leaking sensitive data if it isn't secured the right way. So the crucial point here is how you secure it. With post-filtering, the AI grabs all the relevant documents first and then tries to filter out what the user can't see. But it's already too late. The AI has seen the sensitive data. The secure way is pre-filtering. OpenFGA filters the documents before they ever get to the AI, making sure it only processes information the user was already allowed to see anyway.
Let's see this in action. Imagine a user asks their internal AI assistant for a summary of a top-secret project, Project Odyssey.
Now, if the CEO asks, the system checks her permissions, sees she has full access, and gives her the complete summary, including those sensitive financial details. Perfect. That's exactly what should happen.
But now, what happens when a salesperson asks the exact same question? Well, the system, using OpenFGA, checks their permissions first. It sees they are not authorized to view financial data, and so it redacts that information from the answer. This is the magic of pre-filtering right here. The AI never even saw the confidential numbers.
This isn't just some neat trick. This is the future of how we build safe, trustworthy AI systems that work with our private data. So, what are the big things to walk away with here? First, fine-grained authorization isn't a nice-to-have, it's absolutely essential for AI. Second, reback with pre-filtering is the best way to stop data leakage in RAG pipelines. Third, OpenFGA is a scalable, developer-friendly tool to make this happen. And finally, remember this same logic applies to controlling which tools an AI agent can use, not just the data it can see. And that really leaves us with a final question for you to think about. As you build and adopt AI, are you treating it like a secure colleague with clear, defined boundaries? Or are you accidentally creating an insider threat that has the keys to the entire kingdom? The difference lies in getting authorization right.